My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 504. In this lecture, we will try to understand business constraints and metrics. So now let's look at some of the business constraints and objectives for this task. First thing is, we may not be very worried about latency constraints here. For example, given a pair of users UI and UJ, we are not in a hurry to determine whether there should be an edge between them or there should not be an edge between them, because the way the most of the social networks would compute is they would actually update these predictions UI comma UJ on regular basis. Probably they could do it twice a day. Let's say UI could be following U10. Let's say UI could be following U10, U52, U36. Let's say these are the top 3 people that UI should be following. If I pre-compute this, which one UI is following U10, U52, U36. If I pre-compute this information, this whole information, whenever UI logs into the social network, I can just show to them that yes, you should be following U10, U52 and U36. I need not compute that UI should be following U10 at the time UI logs into, because there is no need to have extremely low latency requirements. You can pre-compute that UI is following U10, U52, U36 and store this information in a hash table data structure and bring it up whenever UI logs in. So we don't have a strong low latency requirements, because you can pre-compute you can pre-compute it. That is number one. Number two is, we want to predict the probability of a link. For example, if I have UI could be following U10 with probability, UI could be following with probability, UI be following U10 with probability 0.9. Let me assume UI following U52 with the probability of 0.7. These probability values help me in ranking, isn't it? So we want to actually have the probability scores of we want to actually have the probability scores of a link being present, isn't it? Similarly, what we want to do is, at the end of the day, we want to suggest connections, isn't it? Suggest connections, or we want to suggest for each user UI. You want to suggest these users UJ which are most likely to be correct, and we also want not to miss out any connections which are important, isn't it? So we want high precision. What we want? We want high precision. If I recommend UJ, I want to have high precision. There should be a very high chance that UI should be following UJ. I also want to have high recall. If UI should be following UJ, I should be recommending UJ. That's what the precision and recall are, as we discussed about these matrices. I already discussed about these matrices. So ideally, I want high precision. I also want high recall. So many metrics which are sensible for this problem. One metric which is sensible is simple F1 score. Yes, which will be using in this case study. Very simple, isn't it? F1 score is high whenever F1 score is high. F1 score is high whenever precision is high and whenever recall is high. There are other very reasonable metrics. For example, there is a metric called precision at top K. So the way precision at top K works like this. Let's say my top 10. So precision at top 10 says for a user UI, if I have 10 vertices U1, if I have 10 vertices, let's say stop for user UI, if I have 10 vertices U1, U2, so on, U10, UI is following U1 to U10, being a top 10 most users that UI should be following, how many of them are actually correct? This is called precision at top 10, because in most social networks, you don't get to show all the users. You have only the limited space. So since you have only limited space, if I am recommending 10 people to user UI, how many of them are actually correct? How many of them should UI will eventually end up following? That's what you want to predict. So precision and top 10 is also very sensible metric. But as far as this case study concerned, to keep things simple, we will try to optimize for F1 score. There are multiple metrics which make sense. There are multiple metrics here which make sense. As far as this case study is concerned, we will be using F1 score, but we could be using precision and top K also. So the business constraints, no low latency requirements. We want to predict probability of links so that we rank order and we want to have high precision, high recall. Hence we are using F1 score as a metric. We could be using precision at top K also. I request all of you just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.